collecting and processing Git logs. I'll probably cut the story short on how I came to this. At some point, I just needed to take the logs of the Git and see what was going on in it. And that's actually where the whole story began. It started with the fact that it turned out that you can't just go and look at the logs of a guitar, because there are different problems. What did I expect when I started working with this topic? I expected that pipx install would install a package, for example, gitstat, and then the console command would create an HTML report with graphs. But it turns out that there are so many solutions on the market. Most of these solutions are scripts, in Python by the way. Since I was a front-end developer, it was a bit hard for me to put, well, I had to put Python, figure it out, fix some bugs. Some of the scripts that generated something, they generated broken builds, and it was very difficult to see the statistics. And if statistics were collected, they were of a kind of this kind. That is, I get a black and white graph in the console that shows some number of commits before and after. Well, it's not particularly interesting. What do we have in the Git? By default, we can type in this thing, and it will spit out some log to us. And it's basically the same as if I download some package and put it in and get this black and white graph. There's some solutions out there for the windup. They have windows, they have some graphs, but somehow they are very weak. You download an exe with something you don't understand, run it, and together with MYL agent you get, I don't know, 2 to 3 graphs. That's not what I want to get from some package on the internet. What do we have? We have an idea. There's a Git thing in the idea. We can do different operations. We can see, for example, which branches, who is the author, and all sorts of other information. And in general, this thing, which is in the idea, it is more functional than an exe that I can download and put on my computer. What other packages are there? There are packages that draw, for example, graphics in the form of animation of some kind. You run the script, it makes a video that shows how your project is gradually growing, new files, new developers, and makes some animation. It's cool to watch if you're a developer, but I'd like some dashboard with graphs, not animation. And in general, if you dig really long, you can even dig up this kind of thing. This is a kind of dashboard that will show, for example, the number of commits, some amount of code that was poured into the project. That's basically what I wanted. And it covered probably all my needs. But the question arose whether it was necessary. Not really necessary, because there are 2 of these things. A little book of graphics that convinces everyone in Russian. And an article on Hubra, where they deal with the topics in great detail, that you can look up in Git. Can we keep it down a little bit, by the way? I can feel the echo. Yes, there are different things. These things say that looking at the total number of commits or the total number of code is a generally useless task that tells us absolutely nothing. And we need to look for some patterns and say that Petya commits I don't know, 10 commits a day, and Masha commits 1 commit a week. We need to look for information, something like nobody commits on Friday, and see why no one commits on Friday for a year. Maybe we have Friday off, we are in Israel, maybe we have some problems on Fridays or something else. And that's exactly the kind of information that needs to be dug up. What metrics do we have in general that we can take out of this Git? And from development in general. The first is the volume of tasks, what the business is interested in. That is, we have a certain team, and we want to understand how many tasks this team solves in a certain chunk of time. The second is delivery time. That is, when an analyst comes to us and says, dudes, I have a cool feature, now we need to roll it out. He gives us a sale, and we need to figure out how much time it will take to write there. TWA write the code, test the code, DevOps will pour this code, and the code will get to production. And the third metric is code churn. Usually they look at when you wrote some code, poured it into a prod, the prod broke, and then the next dude came after you and was like, let's roll back his code. And these moments when the code is rolled back, they are also very interesting, because it is not clear. What is the reason for this rollback? So we had some bad analytics, and we need to redo the analytics. Or we had some bad testing, and we need to redesign somehow the testing process and so on. Is there any way we can solve that with tools? Yeah, sure. We have Linear B, for example. We have a startup called Hatika. These are these things in the form of big dashboards that, accordingly, they try to understand these metrics, and there in the corner there is cycle time, breakdown, just delivery time, delivery of features. How do these things work? You go to the site, you leave a request, their salesmen come and sell you a big SaaS package that integrates with Git, with Jira, with Confluence, and so on and so on and so on. These things collect absolutely all the information they can get their hands on from various sources and output some kind of dashboard with how long the task is traveling from analytics to production. In general, this is cool, but there is one nuance. If you work in a company and want to quickly view metrics, you won't be able to do it because you don't have the ability to install a product with dependencies. If you work, for example, in a bank, to install something that will take code from the bank, it needs a very long and tedious approval. And it is unlikely that anyone will coordinate it, given that the company is foreign. In 2018, there were two dudes who decided to write all the same thing, but in the Russian segment. And this is a screenshot from TeamLitConf, you can check it out. The dudes wrote something very similar. They had a very cool report, but after a year they closed down. And they deleted their website, they don't have a repository left where you can download. Anyway, we know for a fact that there was something, it was cool, they showed it at different conferences, but in 2024, there's no artifact left of them to use in any way. So, what do we have? We have something that we can't just pick up and look at, and if we were able to pick up and look at something, there's no metric there and it's not clear why we should even look at it. So we start writing a bicycle. What do we have out of the box? We have git, and git has a log command. Accordingly, all the log is already on our computer, so we don't need any integrations to pull that log from some system. If we have downloaded the repository, the log is already there anyway. And we can add some parameters to this log command and already output some information. Or we can write a lot of parameters and at the end do such a thing to spit them out into a file. We will get a txt file and then we can somehow parse and process this file. Well, and in general this scheme has turned out. We type a command in the console, it spits out a file to us, we parse this file, throw it into the browser, and in the browser we draw some nice graphs, pages, reports, and so on. That is, at this moment we do not have the moment of installing anything on our computer. This is roughly how it all looks like, and this is approximately the report we get. Well, in general, you may not throw all this into the browser, because it's a bit strange to take your code, take logs from it, and throw it into some obscure site. So you can just type pipe.install.assayo and all this stuff will be generated in your repo. There will be about 40 slides where we will look at what we have in the logs and try to understand and analyze something from these logs. And we are going to analyze how we can get this or that information. Imagine a situation when you come to a new project, you know nothing at all about this project or the company. No, of course you know something. You came to Lesta game and they threw you some reputation. You are going to, I don't know, commit the next 1.5 or 2 years of your life in it. This is what a set of unique strings in any Git log file looks like. What do we have? First of all, we have the date, having a date and a last name. The last name of the dude who did the commit. With just these two parameters, we can, for example, make a list of people who are currently working on the project. Well, and not only at this moment, in all the past moments of this project. If a person commits regularly, we can assume that he works in the company. If then this person disappears from the log, that is, he made commits in January, in February, in December, and some month comes April, and we don't see this dude in the logs anymore. He probably quit. We can mark these guys who worked but quit. And it can happen that a person works in a neighboring team, he commits once every 6 months, and we realize that most likely this is not the main dude from this project. It's some kind of helper, maybe DevOps, maybe a tester. Sometimes he shows up in the repository, sometimes some commit shows up from him. We can't tell if he's working here permanently or if it's a temporary bot of some kind coming in. But we can mark them simply as some kind of helpers. That is, we can evaluate the general environment of the team. For example, there is a backend team and there are, I don't know, 20 people, testers, DevOps, analysts, and so on. What can we look at here? Well, let's say that we are interested in a person's work time, and we can see that in this team, on average, people work for 1.5 years. You come to a new project, look at the log and realize, aha, on average after 1.5 years you should update your resume and look for something new on the market. We can look at some general metrics, like how many are currently working, how many have quit before, how many roughly. I don't do tasks per day. So you may be sitting there thinking, I am working very little here, and then you look at these indicators and think, no, I am working on average. I mean, in general, the speed of the team has not changed since I came here. We can put all these commits on the calendar and see what's happened to the team from some point in the past to now. Let's take a look. We see 2 new names in the draft. Accordingly, we make a plus sign that we have people coming in. These people write something, and then there is such a thing that they start committing on weekends. That is clearly some kind of overwork. Most likely they commit for a full week, and then sit on Saturday and Sunday. And then a few more new people get thrown in here. We realize that they've probably had some kind of backlog, and to clear that backlog, they start expanding the team. Then one person leaves for whatever reason, sometimes they continue working on weekends, and some rework starts again. November, December of the next year comes, again the guys sit on weekends, and look, in November a new developer is added to the team again. What can we say as a new employee who came here?
Number 1.
These guys have weekend work. So we're guaranteed overtime.
Second.
You don't have to plan a vacation for November, December. I don't know what this team is, what their project is, but I know that every year, November, December, January, these guys are going to sit around and work weekends.
I don't know why.
Maybe they have some seasonality in their project. Maybe they have an audit going on there for the new year, but it's a steady thing that we see. And what do we see? What we see is that at the end, developers start quitting, and we're left with probably one dude who's taking his time doing the project. Maybe again, we don't know what it is, but it's clearly past its best years and left as a legacy on some source support, because the team has scattered, the rework is gone, and we're left with someone alone who takes his time and just commits every now and then.
That's great. What else do we have?
We've got. Sometimes we have task numbers mentioned in the text. We can find the task numbers in the text of the commits themselves. Maybe a branch is signed with a task number. So in large companies, usually a task number will slip somewhere in our logs one way or another. And the type of task may also slip in our log. For example, in Bitbucket, if an office is running, when a person creates a branch, the branch has to select the branch type, like it's a bug fix, a release, and so on. We can put this whole thing together again and make a table, like a list of all the tasks. At first glance, the thing is completely pointless. But we had a situation where the task tracker changed in the middle of the year. We were sitting on a Geary, then import substitution happened, and we got our own task tracker. At the end of the year, an audit came to us and said that we had 200 unclosed tasks, and we had to somehow prove that these tasks had been closed. One of the options is to pull up the log, find the numbers of tasks, authors, and pull requests, and then report to the audit. Also, if you have some problematic task, you can find it and see what releases it went to, if it was reopened several times and each time it was pushed to some next release. If we take all these tasks and spread them out by week, we can make a graph of how many tasks per week the team closes in total. And what we see here is, this thing is that there are 2 people working in this team, and the number of tasks is decreasing every week, and this picture has been stable for the last 3 months. What can we say? First, it's not clear if these are the same type of tasks or different tasks. It is not clear whether they are the same people or different people, and who set them tasks, on what principle. If we work side by side and we encounter the same people who set tasks of the same type, then probably the team's workload has simply decreased. That is, the volume of tasks has simply decreased. We also see that there are quite a few days without commits, and there can be 2 options here. The first option is that the dudes have some complicated bug fix going on, when they spend 3 days looking for a fix in a couple of lines. Or the second option, they really don't have the code. If we are left with an open question with a backend developer, it's easier with a front-end developer or layout designer, because it's unlikely that they will spend a long time looking for a bug that can be fixed quickly. Chances are, he or she could have just rolled out a bunch of new pages in that time. Okay, all of this can be put on a dashboard and looked at on a per individual basis. And there's another thing that is actually practiced more often in outstaff offices. It has to do with the fact that we need to write off time every day for some nonsense. Why outstaff offices? Because they bill the customer, they need to bill for something. Well, for example, we allocated a backend developer who worked 120 hours, and in those 120 hours he did this number of tasks, he needs to be paid this amount of money. In most cases, all those hours are such an absolutely routine work, when you just need some number of tasks to be smeared on some schedule. But it's usually done by hand. For example, in the tempo plugin in Jira, when you take a task, you click there took to work, finished work. In general, all of this can be collected from the Git logs and not filled in by hand every day, but just at the end of the week to see what you did and spread it out evenly over the week or the month. And if we're looking at some other department, we can see how much code they've injected. For example, what do we see here? We see that someone is firing 4 tasks a day. But we look at the amount of code he injects, and we realize that these are some small tasks. And most likely, the dude slices a bunch of small tasks with a small amount of code on purpose so that he can have visibility every day for some reason. We don't know what this is for. Maybe it's bad, maybe it's good. We just know it's a fact that it's common here to slice up small tasks, and for some reason they do it. Okay, the story about changing contractors. There were guys sitting in Serbia, and the story happened that there were some guys, they were sitting in India, and the guys in India met the guys in Serbia. And when the guys in India met the guys in Serbia, the guys in India realized that now their office will be well, because it is unlikely that 2 offices will work on the same project.
What did they do?
They transferred the code and removed some of the modules. So the guys in Serbia got the code, and the code wouldn't run at all. They started looking at it, trying to figure out what the previous team had deleted so that they could somehow explain it to the customer, because the situation turned out to be ugly. You got the project, but you can't run it, and you kind of have to give it back to the previous subcontractor. So looked at the information about the files that were changed, and we have labels, how many lines were added, how many lines were deleted, added a file, deleted a file, changed a file, and so on.
And made a file tree.
And in this file tree you could see, for example, the volume of files, where there are more files, where there are less files, who changed, who deleted, what was deleted, and so on. And accordingly, in this way we found some pieces that, well, whole modules that the guys from India had simply torn down before handing over the project. What else can we look at here? Our file names sometimes contain not the extension, but some other addendum.
For example, here we have test, and when it says test,
Of course, we don't know what is in this file, but it is most likely to contain tests, because tests usually write something .test or put them in some test directory. Accordingly, we can make a kind of table where we specify all the extensions that are in the project and all these extension subs. And see, for example, that there are very few tests in this project, but they are not just few. Somebody deleted 96 tests. They had a total of 100 tests, and some event happened. Let's say, from a template perspective, it's a good question to investigate what happened in the team that they decided not to increase the number of tests, but to drastically reduce them. Well, also if you need to do some rare file, like config and jinx, yeah, they said to add it, or some other config for Docker, you can open this thing and see that actually someone already did this task and this file was added and then deleted. And you can dig up all that history, find the task, who added it, why it was deleted, what was in that file. Maybe you kind of don't have to do much, you just have to find the previous task, who did it, how it was done, and recover his code.
What else do we have?
We have information about the pull request in the logs. And the pull request has task numbers. So we can connect the task number to the pull request number. And that way we can build a table of all the pull requests that were on the project. What are we interested in knowing, for example, from a template point of view? We're interested in this column here, days of waiting for infusion. We don't know what kind of team this is, but they have something going on with their processes, and that something is causing them to not freeze pull requests for 3 to 4 weeks at a time. Well, specifically in this case, for example, there was a testing issue here, and development was overtaking testing by about 2 months. So when developers finished their work on the backend, they were left with a pull request that hung around for some number of weeks, and no one could pour it in. Accordingly, if there's a top level there, it may not be visible, but you can get that information from the log. We also have branches labeled release. Usually, let's say, they are cut off to create releases, and DevOps hang different things on them for automation. And we can pull up all such release branches, see what merges were in these branches and make, for example, like this is not here for some reason. Make a release schedule. Usually the release schedule is kept as some kind of documentation, but in general, we can pull it up from the logs. And there are some interesting points that may not coincide with the documentation. For example, we can see that we had a delivery and some task in it took 20 days, which is quite a long time. In general, we can see that releases in the office are frequent. Every week the guys give some release. But let's say there was a release on April 22nd, which was delayed for 2 weeks. And if you go in there with an audit, that's a reason to start investigating why they had this release derailed, why, let's say, the tasks took a long time to form for the release, and how this kind of thing happens in the first place. Besides, in my department, for example, you can find out that some of the tasks that are included in the release, they do not coincide with the documentation that is kept with the official release. Because here this thing is obtained automatically, while the documentation is filled in by hand, and there are some reasons that make people pour code past the documentation. We went through all actually 3 options. We looked at the volume of tasks, delivery time, and code churn. And with about such a report, I came to the front-end confab 2 months ago. The guys listened to it and said 2 things. The first one, then, is the idea of refactoring. If we can see all the files in a project, we know how many days were spent on a file, how many tasks were related to that file, and how many people worked there, as well as the number of lines in that file. We can automatically generate a list of candidates for refactoring. I don't know anything about some project, I take its log and see which files there are 500, 600, 700 lines, who has changed their 20 times and suggest, for example, to write tests for some file. That the tests are not written, I can also see from the neighboring files, because I have a complete file tree, and I just look to see if there are rows of files with test extensions somewhere. The second idea was mail. In this case, let's say mail.d doesn't tell us anything. It's some ordinary, I don't know, mail server like gmail.com, but very often, when we commit some code, we commit it from corporate mailboxes. And these corporate mailboxes usually have the name of the company where we are employed or where the developer is employed. We can take the log, parse it, and extract information about the subcontractors that worked on the project before and after, and make slices for each office that we find. For some big office where you work 5 days a week, this may not be of much interest. But if there's some open source, I don't know, we'll take repo React or pipx and we might find out that, let's say, guys from China are trying to change some module all the time. And we haven't seen these guys from China before. With the help of the company's internal monitoring, we can accurately determine when an employee, for example, from Intel or Microsoft, starts working with open source code from Iran, and he will immediately receive an email warning. Yes, in fact, it actually turned out that this is not all that can be spun. And if you spin it further, you can see the timestamp. And if you take the timestamp, if you take the email domain, you can, for example, map out all the people who were approximately committing to this repository and spread them around the planet. So what do we have? We have Telegram desktop. I took the GitHub repo, downloaded them, and found out that despite the large number of maintainers that we can see on GitHub, there are basically 3 dudes working there. 2 of them are from 2014 and 2019, sitting somewhere around Armenia and Georgia, and another one is sitting probably either around Moscow or Turkey, judging by his time zone, email, and a bunch of some other metrics. Or the Linux story. You've probably heard what's going on right now. Russians are being kicked out of maintainers. If you download the Linux repo and analyze the log, you can see that out of 26,500 developers who made changes to the kernel, the main work is done by about 500 people. These 500 people wrote sort of the majority of the code. And overall, if you look at how many, for example, Russians were likely to commit to Linux, it turns out to be about 756 people. By comparison, in India, 1,600 people were committing there. But there is an interesting point here. You can look at the number of tasks, number of commits, uptime, and so on. And it will turn out that even though fewer people did the work in Russia, for example, they did it for a longer period of time. So these 1,600 people from India, that's 6% of the total, they basically went in, changed one line, got an achievement that they added something to core Linux and left. How can we spin this up?
We have a timestamp.
So the first thing we do is we spread them out over time zones. Once we've spread them out across time zones, the next thing we can see is that, for example, now we're going to have to switch. There are unique time zones. For example, India is plus 5.30, and no one else has plus 5.30. Accordingly, if we saw plus 5.30, we probably hit India. Plus, I don't know, 5.45 is Nepal's time zone, and no one else gets into it. There are unique cities like Adelaide in Australia that have a 10.30 zone, GMT plus 10.30. And if you see GMT plus 10.30, that means you're probably in Australia. And because it's mostly desert in that time zone, that leaves only one major city, and that's Adelaide. There are situations where we get to the junction of several countries. That is, we hit, but they're in Europe, and there are many countries on the same time zone. What can we do? First, we can look for unique symbols. The Israelites, the Germans, the Latvians have letters that are not found in other alphabets. We can look to see if that letter happened to be in commits somewhere to determine what the country was likely to have been. There are also the most popular surnames. For example, Korea and Japan fall in the same time zone. But the thing about Korea is that the surname Kin, or Won. If we take all those people, there are about 25 million of them. Accordingly, out of that Korea-Japan sample of 25 million Kims, we can immediately pull out and say that these are probably not Japanese. It's the same for Japanese with the surnames Sata and Suzuka. That's somewhere around 4 million people. Accordingly, despite the same time zone, we can clearly understand who it was.
What else is there?
We can immediately compare, for example, popular email services. If we come across a dude with QQ.com mail, most likely he is Chinese, because QQ.com is a Chinese mail service, so everything is in Chinese. It's unlikely that a dude from another country would just go in and register something. There are some very problematic areas,
Like China and Singapore.
a lot of developers in China, a lot of developers in Singapore, and it just so happens that there are a lot of Chinese people in Singapore, like a quarter of the population. And we can't understand, like, is this Chinese person from China, from Singapore, or from Taiwan? And that's where it's going to be a miss in general. This system doesn't work accurately, but on the average ward it predicts about 80%. So there's an 80% probability we'll guess where the developer was sitting. Everything I said can be automated, and you can pull out some automated tips. You throw a log, this thing already looks at some scored metrics and shows that here, for example, development has slowed down, or there are not enough tests, or there are a lot of people getting fired, and so on. You can give archives to the developers. So you've made a pull request that's been on review for 5 months.
You get an achivka tomorrow. And so on.
Achivkas in general are divided into positive, negative, and negative. Negative ones are given for some bad actions, positive ones for some good actions, neutral ones are given simply because they are given. No special conditions for them are necessary. Everything I said is available in Russian, in English, there is a site where you can try it, there is Docker, and there are tons of packages. Accordingly, if you write in Python, you can deploy a package in Python and see it all for your repo. Or you can look it all up on GitHub. The next to last question is microservices. It happens that we don't have a monolith, but a bunch of separate microservices, and we need to somehow collect information on all microservices and define it. But in general, for this purpose, there is another package that runs through different repositories, collects logs, glues, and gives you one file for, 200 to 300 repositories.
I'm done with that. Let's clap.